Okay, so we're back again on that problem 4.1, number 19, derivatives, acceleration, velocity, and position functions. So we had the problem where the car is traveling 45 miles per hour, is brought to a complete stop at constant deceleration, 132 feet from where the brakes are applied. Round your answers to 2 decimal places. So the first question says, how far has the car moved when its speed has been reduced to 30 miles per hour? So immediately you start thinking about, I don't know, what do I know? So you start to build your body of information. So you say, all right, well, I know that this is, and you might start over here where you say, well, what are my equations? And you can get the structure for your equations just using A. And acceleration is A, negative A in that case, because you're decelerating. So the acceleration is negative. But then first I would say, okay, I need agreement between my units. So I have 45 miles per hour and I have 132 feet. So what I did then next is I thought, okay, well, let's change it to feet per second. Okay, so I changed the 45 miles per hour to feet per second. And I just wanted to hone in on the fact that you're going to multiply by 1 hour over 3,600 seconds times 5,280 feet over 1 mile. Do a unit conversion, you get 66 feet per second for 45 miles per hour. 30 miles per hour is being asked about in the first problem and 15 in the second problem B. So 50 miles per hour is 22 feet per second. All right, so once I've done that, then the second step is I'm looking at my equations to find out, I got to find out what A is. So I got to start somewhere. So since I don't know what A is, I kind of work it through and I say, all right, well, I got V then. Once I have A, it's just negative A here. And then I can take the antiderivative to get V of t plus C. And then I can say that, well, initially the car is going 66 feet per second. So I plug in 66 for V of t. V of 0 is 66. And then, of course, 0 goes in for t. And I solve for C and I get 66. So then I now have my velocity equation. Then for my position equation, I can randomly state that, all right, I'm going to say t equals 0, the position is 0, and then it goes 132 feet after that. So then I can find out that d is equal to 0 if s of 0 is 0, so d has to be 0. And I have my position function. Now I don't have my t value, but I have information about t. So now let's look at step 3. Step 3, I know that the velocity is 0 after 132 feet. So I set the velocity equal to 0, and then I end up with the t value being equal. Solving for t, I get 66 over A for t. Now, you do know then that just like with the velocity being equal to 0, we had the velocity equal to 0 here. That gave us information. And then the position, this position is 132. So I have that. So I'm able to plug in 66 over A in for t, the time we got in step 3. And I'm looking at that. I solved it, and I got t is equal to 16. A is equal to 16.5. So now I have A is equal to 16.5 here. And then I'm able to carry that over into step 4 to say now, okay, I know the equations because I had A. I already found A. So I reformulated the equations, right? To A of t is equal to negative 16.5. V of t is equal to negative 16.5 t plus 66. And S of t is negative 8.25 t squared plus 66 t. So I have my 3 equations. Then we're saying how far has the car moved? So you want distance, right? When its speed has been reduced to 30 miles per hour. So I want S to be 44, but I really can't plug it in. I can't say I can't figure out by putting the t value into the position, I can't figure out what the distance is without knowing what the t value is. And I have to do that by using 44 feet per second at 30 miles per hour. I know that velocity. And I can solve for t, and I get 1.33. Once I get the time, then I can go ahead and plug it into the position function, which I do, and I get 73.333 feet. Okay? So the answer to part A is right here, 73.333 feet. That's how far the car has moved since when its speed has been reduced to 30 miles per hour from 45 miles per hour. Okay. Now, the second question says, how far has the car moved when its speed has been reduced to 15 miles per hour? So we've done all the hard work in the initial part, and we then find that for this part, we say that the velocity is 22. The velocity is 22. Now it's 22 feet per second, 15 miles per hour here. So it's 22 feet per second. We solve for t and we get 2.667. Then we plug that value, 2.667, into the position function. We get 117.33 feet. These are supposed to round it to the nearest hundredths or 2 decimal places. All right, so now I've got my values. Then the third part of the question is draw a number line of the situation. Now, and then I also looked at what the t value would be. So we got almost all the way through this problem, and I kind of wanted you to sort through it. I hope you did take a little time with that for number 19. But drawing a number line of the situation, I would look at it like this. You know, so you start at 0, and then we know that we're going to end up at 4 seconds. We then pass through 132 feet right here. And you can see that the first, at 30 miles per hour, that's when the car is at 30 miles per hour, it's at 73.33 feet. And then at 15 miles per hour, you're going 15 miles per hour less there. It takes 117 feet to slow down to 15 miles per hour, okay? And so in t equal 4, then you end up with a velocity that's equal to 0 there, okay? So now the question is what... I think there was a last question in there, but it pretty much takes, if we just talk about this for a second, it takes 1.333 seconds to reduce the speed from 45 to 30 miles per hour. 1.33 seconds to reduce the speed, so another 1.33 seconds to reduce the speed from 30 miles per hour to 15 miles per hour, and 1.333 seconds to reduce the speed from 15 miles per hour to 0 miles per hour. Each time, less distance is needed to reach the next speed reduction. So I think you had one more question on there, right? So this is the answer here on that one. Less speed is needed. Okay, I hope this video was helpful in going over this homework problem, and I will see you tomorrow. And if you need to review this, then by all means, rewind and watch it again. And I'll see you tomorrow. Bye.